All right, this is reviewing for the first semester final for Algebra 2. First up here is complex numbers. So we are going to want to simplify the quantity 1 plus 2i times the quantity 5 minus 3i. Since we are multiplying here, this simply means that we FOIL or double distribute. So we'll distribute our 1 to both. So we will have 5 minus 3i. Distribute our 2i to both. So we will have plus 10i minus 6i squared. Recall for complex numbers that I equals I squared equals -1, I to the third is -I, and I to the fourth is 1. So this I squared here is really a -1. So this is really minus 6 times -1, which becomes a plus 6. So we have 5 plus 6, which is 11. And then we can combine our i's together because they're like terms. So -3 plus 10 is 7. So this would be 11 plus 7i. Next up for the complex numbers, we have 2i over 3 plus 6i. Whenever we have addition or subtraction in the denominator with a variable like I or a radical, those are not simplified. We have to multiply by the conjugate. 3 minus 6i. Multiplied both the numerator and the denominator. The numerator, it's pretty straightforward. We just have to distribute. So 2i times 3 is 6i. 2i times minus 6i is a -12i squared. The denominator we have to double distribute or FOIL. So 3 times 3 is 9. 3 times 6i is minus 18i. 3 times 6i is a plus 18i. 6i times -6i is a -36i squared. Notice here these 18i's cancel, so we are left with 9 minus 36i squared. Once again, we have some I squareds here, which we know really give us -1. So this is actually saying 6i minus 12 times -1 over 9 minus 36 times -1. Or 6i plus 12 over, this would be 9 plus 36, which is 45. This is now only simplified if all three terms have a greatest common factor of 1. That's not the case. We could divide both the numerator and the denominator by 3. 6 divided by 3 is 2, so 2i plus 12 divided by 3 is 4 over 45 divided by 3 is 15. So 2i plus 4 all over 15 would be our simplified solution here.